Okay, so we just did resting membrane potential, and now what we're going to do is we're going to depolarize our cell. Basically, a stimulus is going to come through, and it's going to help us flip our charges. So when we depolarize, we want to just kind of think about what's happening in depolarization. Here, what we want to do is we want to make the inside positive. So the inside is going to be a positive charge, and the outside is going to be a negative charge. I'm just going to move some stuff around. Whoop. Ah. So our outside, we want to make negative, okay? So we're going to set this up again, and I'm going to set up a couple of things in this. I might not use this one. I might just kind of cut some stuff in half, but we're going to still set up like we have our sodium potassium pumps, and I'm just going to draw in 2 sodium potassium pumps really quickly. Then I'm going to draw in now my sodium voltage gated channel, and I always make it into a triangle based on the direction that the ion's going to flow. So it's like a funnel, and you know which direction it's going to go. So like that. And I'm also going to build in a potassium pump here, just in case I'm going to use it for my next portion as well. So we want to think about, we have all this sodium on the outside, just a little bit of sodium on the inside. Okay, and that would be the same for over there too. And we have a little bit of potassium on the outside, but much more potassium on the inside. Okay, so we are a negative 70 millivolts on the inside and a positive on the outside. What's going to happen is we're going to have a stimulus here. So that stimulus is going to be received by the dendrites, and it's going to be sent over to the axon. So that stimulus is usually opening up some sort of a sodium channel that is going to bring sodium in. Okay, so you're going to have something that causes the cell to change to become a little bit less negative, a little bit more positive on the inside. And because of that, what's going to happen is that's going to open my sodium voltage gated channel right here. And when I open my sodium voltage gated channel, what you should see is you have a high concentration of sodium outside of the cell and a low concentration of sodium inside of the cell. And that's going to cause my sodium to want to move inside of my cell to cause equilibrium, to equalize, okay? So what was once negative on the inside now becomes positive here on the inside, or becomes less negative. Okay, so we're just going to think about it's going to become less negative, and it'll become less positive on the outside. So we were at a negative 70, now we're probably at a negative 55 millivolts. So then negative 55 millivolts is going to be our threshold level. As long as we reach that negative 55 threshold level, bringing in enough sodium, essentially what happens is that's going to trigger our next sodium voltage gated channel down the line, down the axon, to open. And as that opens, we should see that there's more sodium down there. I just didn't draw it in because drawing all those tiny little things takes time. It's going to cause sodium, more sodium to enter. I'm just going to do Na plus like that. Okay. So now more sodium enters. So we were at a negative 55 here, but now we end up being, I don't know, like let's say negative like 25 or something. Okay. So we're starting to become less negative and starting to become more positive. And if you do this over time, you end up creating an action potential. So if you open 1 sodium voltage gated channel and 2, in all likelihood, you're going to open all of them, and that creates the action potential that goes from the cell body all the way down to the axon terminals. That is what our electrical message is. We really need to make sure, though, that our cell doesn't just go to negative 25, that it goes all the way up to about plus 30 millivolts, okay? This is what depolarization is. We're changing the inside to be positive and the outside to be negative. And we're going to do that by pulling sodium in by opening our sodium voltage gated channels. So let's do this electrical graph, and then we'll fill out our chart to help us as well. So what's going to happen is we're going to have our stimulus right here. That stimulus is going to bring sodium in. So we're going to have sodium inside. And eventually we end up becoming hopefully a negative 55 millivolts. And when we do, that's threshold. As soon as we reach threshold, you should see there's going to be a spike that goes all the way up to a plus 30 inside of the cell. So our cell is going to start to depolarize right there. And as long as we get to a plus 30 all the way along the axon, this is the action potential. Just like that. Okay, so let's put this in our chart to help us figure this out too. So we can number these. I forgot to number like 1, we could do 2, we can do 3, 4, 5, 6, like that. And we're going to put these on our graph here. So resting membrane potential is 1, and then we saw threshold is going to be 2, depolarization is 3, action potential is 4, just like that. So we can use our electrical graph to help us figure out what's the charge inside of the cell and what's going to happen to sodium, potassium, calcium, and our membrane channels. So I want you to pause right now, and I want you to fill out threshold, depolarization, and action potential, and then see if you get it right. Okay, I hope you paused your video and you saw that threshold has to be negative 55, right? In this case, what's happening is the sodium that was outside of the cell is starting to come inside of the cell. So you should start to see that the concentration of sodium is going to start to get higher inside of the cell. What happens to potassium here? What did you write? Is this still high inside or is this still high outside? Let's go back here. Did I do anything with potassium? No, I didn't do anything with potassium. So we see how potassium is still high inside of our cell. And we're not using calcium for any of these things, so we're just going to block out calcium. I hope you wrote down which channel we used. The sodium voltage gated channel, because sodium enters into our cell. The depolarization is going to be that you're going to go from a negative 55 here to more positive. So we can say either up to plus 30 or up to a non-specific number. The voltage here doesn't matter as much. You should know this voltage number and this voltage number, okay? Again, inside is going to be more positive, so our sodium levels increase, while our potassium levels stay the same, and we're going to open our sodium voltage gated channels here, okay? The action potential, you have to be all the way at a plus, so plus 30, plus 50, it depends on what type of cell it is, but we're just going to go with plus 30. It's a little less important for you to know that specific number. So now inside the cell has much more sodium than outside, and it has a lot of potassium. So this is why it becomes even more positive, because you have all these positive ions that are stuck inside of the cell. In this case, all of our sodium voltage gated channels open along the axon. So it's kind of the difference between depolarization and action potential. It's the fact that your depolarization, you open one or two. The action potential, you're going to open all of them, every single one of them, okay? So at the action potential is going to go all the way down the cell, and it's going to cause synaptic transmission, which we're going to do at the end. But at this point, if you'd rather look at synaptic transmission, watch that video to see how synaptic transmission works. And then you want to think about repolarization and hyperpolarization. So before the next video, I want you to think about, are you ready to send another message down your axon? If you're saying yes, how can you send another message down your axon when you have to be negative on the inside and you are now positive on the inside? Even if you were negative on the inside, you also have to have these conditions here, right? And our conditions after depolarization are much different. So now I need to go back to being negative, but I just pulled in all the sodium and I can't push it out that easily. This is why I'm going to use potassium now, because it's my other positively charged ion that I can move out very easily. So we're going to look at repolarization, hyperpolarization in our next video.